This is lecture 13 in the series of learning about artificial intelligence, and we will look into the breadth first search algorithm in this lecture. So we have seen depth first search algorithm, which was traversing the graph in a depth, and in the breadth first we will visit the adjacent nodes in the first in first output queue method. Breadth first search base is an algorithm traversing or search tree or graph data structures. It starts at the tree root or some arbitrary node of a graph, sometimes referred to as a search key, and explores a neighboring node first before moving to the next level neighbors. So the use of search algorithm, as we have seen in previous lectures, is to find a goal or find a solution from a problem. So the problem, first we have defined the problem and we have put it in form of a semantic graph in our database or knowledge base, and now we are using the search algorithms to find out or reach the goal state. So we can do that using the breadth first search algorithm. In breadth first we go wide in the spectrum as opposed to going deep as in the depth first search. So that's one difference between the depth first search and the breadth first search. And if you go into the working, if you can start at some node, this is now our current node. State that our current node is visited. Now look at all the nodes adjacent to our current node. If we see an adjacent node that has not been visited, add it to the queue. Then pull out the first node from the queue and traverse to it and go back to step 1. So this is how a breadth first search algorithm works, or search method works, and the steps as described here can be used to write a search algorithm in computational language, which can be used in any program which will be used to fetch data from the database using this search algorithm. So you can see a graph with A, B, C, D, E nodes, and at step 1 you can start at node A. Now what you see for the adjacent nodes is B, C and E. Now you can add the adjacent nodes, that is B, C and E, to the stack, and you can declare them visited. Now in your stack there is B, E and C, and now you can visit the first node from the queue in the first in first out order. So you will now visit B. At B you will see that there are two nodes which are adjacent, D and E, but E is already in the stack. So you will now add D to the stack, so the stack will, or the queue will now become ECD. Now you will visit to the next node in the queue, that is E, and once you are at E you will see that there are two adjacent nodes, that is A and B, but A is already visited and B is also already visited, so there is nothing to add in the queue. And now you will go to the next node in the queue, which is C, and at C you can see the adjacent node A, which is already visited, and finally you will visit the node D. And in this way the graph has traversed through all the nodes using the breadth first search algorithm, and this is how the breadth first search algorithm works. Breadth first search algorithm without using heuristic or any cost functionality can be bit time consuming, and for larger nodes including thousands of nodes it can consume huge computational power and time consuming to solve simple problems. So if you see the path which was taken by the graph was given. If you want to read for more, you can go through the reference, and in the next we will see other search algorithms. If you like this video, please do subscribe, like and comment.